Well, good afternoon, everyone. I hope you had a good day. Right, so the webinar for today is talking about Autodesk Insight and how we can use the technology to design more energy efficient buildings. Now, the concept has been around for many years, but let's see how Insight can actually help us. Right, so just looking at the agenda, we're just going to introduce the topic. Then we're going to look at the application and what it entails. And then we're going to conclude and have some questions and answers. Right, so Autodesk has always been, well, at the forefront of energy efficiency. They've actually purchased Ecotect and Green Building Studio back in 2008. Ecotect was an Australian company that did various energy efficiency tasks, and then Green Building Studio was a web-based app that allowed you to upload your model from Revit to this Green Building Studio format, and it will have had done like a whole building analysis, giving you a lot of a report with a lot of information. With that purchase or the purchases, Autodesk has the idea was to build everything into Revit, and it has mostly been done with also the the shadows and the a lot of the information from Ecotect, but it also has culminated in the app called Insight. Right, now Insight has got typically a lot of tools, but there's also one or two solar and lighting add-ons, not add-ons, but falling in the same umbrella that you can also do. Insight being the energy optimization of your Revit model. Right, so all in all, the Insight has come a long way. The technology has been incorporated into Revit and the ecosystem, so the tools are there to be used. Right. Okay, so I briefly explained what is Insight, but it's basically an add-on to Revit that allows you to basically upload your model to the cloud, and it then forms a idea of what you have, and then the ability to optimize your model based on various criteria, and then it allows you as a user and a designer to choose and to perfect this model with energy efficiency in mind. Right, so there's a set of tools, and these tools obviously allow you to define location. Right, so first, that's obviously the first and foremost step, is to define your location, the building's orientation, and that's it's basically inside Revit. It's just kind of a tool that says location. You pick from a Google map, and the location or the orientation is just defining where north is as in relationship to your model. And then once you've done that, you go and look at your construction of your model. Now you can do this analysis, or the insight analysis, or the energy efficiency analysis, based just on conceptual construction. On the other side of the spectrum, you can also do the analysis on actual thermal properties of each wall, roof, floor, etc. So those components could have its own thermal properties, being the K values or the U values or R values or whatever they have. You can base your performance or your energy efficiency calculations on that, or just a global kind of setting that's based on just the whole building conceptually designed. Now, in the little image below, I've just made like a screenshot of the energy model, the conceptual energy model, and its construction. So if you look at the dialog box at the bottom, it'll just basically list certain construction for external walls, or exterior walls, interior walls, and that sort of thing. So that's just kind of an overview or a conceptual construction. As I mentioned, the other side of the spectrum, each wall could have its own thermal properties and R values, and that you can also include in this performance analysis. Right, once you've got the energy model, however you decide, be it say just a conceptual one, you will then go in the process of optimizing that and then uploading it to the web-based application. And it will just give you a result very similar to the little screenshot there in the top right of that top image. I'll just point it out with my cursor. There's a 36.7. So that is a number or an amount, and you can obviously set what it should be. In that case, it's kind of US dollars per square meter per year, but you have a different numerical system that you can use, or generic system that you can use, that just has a number-based system. And obviously, the changes that you make will influence that number. Obviously, trying to reduce that to close to zero as possible. All right, but once this is now uploaded, this is then this kind of starting point. Right, it does take a while to kind of process, so kind of 5 to 10 minutes to just kind of process a model. Right, but once you've uploaded that, you have then the ability to look at each component within that model. From the lighting, from HVAC, roof construction, wall construction, the fenestrations, like the windows and doors that's glazed, and each of those form a factor and to that initial value that we saw, that 36.7. So the more efficient you have these parts, or the more efficient these parts are, the better the number on the whole building. All right, so what you then do is you look at each of these components, be it the northern walls or the roof construction, and as you change the particular item within the website, it then changes the little picture here on the bottom. The little triangle is how the BIM model got uploaded as. So the value of that particular model that you uploaded is the triangle, and there are other instances of it that could be more costly, or other instances that are obviously more energy efficient. So you would want to aim for the roof construction to be more energy efficient. So if you do select the column, or that little column on the left-hand side, or on the right-hand side of that area, it'll reduce the overall construction, and it will give you a new number. And notice here there's a roof construction and a roof construction. So as you optimize each of those things, it will just in real time give you feedback on this website. Right, now, just clearing up, you've only changed the website. Your model in Revit hasn't changed yet, but at least you now know what, if you do change it in your Revit model, what influence factor it's going to have. Meaning that maybe you add insulation to your roof, and it will then have a specific influence to the energy efficiency number or factor to that model. And once you have that optimized in Insight or on the website, all those various components. It will give you obviously a benchmark and against other people and other standards. There's an ASHRAE standard and there's an Architecture 2030 standards from Americas, and you can see if you need to kind of be more robust with the energy efficiency, or if you just need to kind of just stick where you are. Right, once you now have then decided that, you can then go back to your Revit model, maybe go and change the roof construction, maybe go and change the orientation, maybe change some of the R values in your windows or your walls, add maybe insulation to your walls, re-upload it, and obviously then get the results. But it's kind of an up and down workflow. It's an iterative workflow. So you optimize your model, upload it, check what the results are, further see if it you can further optimize it, and then go back and in Revit change your model. Right, and then upload it to get the final results. Right, once you've got the final results, meaning that you've now optimized it as much as you can, you can then export this in various formats from the cloud back as a report. It could be kind of there's different formats. You'll see there's energy costs, benchmark comparisons, and all those little widgets that we saw earlier for further analysis if needed, or just as a report, right? And that obviously then matches your Revit model, because that was the last uploaded model that you have done. Right, so that allows you to do that, and it's actually, that process is very smooth. It's a little bit of learning, but could help a lot with the management and the energy efficiency of that building. Right, then there's two other components that you can also look at to increase your energy efficiency. And the first one is your daylighting analysis. It's not web-based, so it's not included in that whole upload of the Revit model. It's done within the Revit environment. You'll see at the top right of that image, you'll see there's a solar and a lighting button. Now, what you do, obviously, after setting the location and the orientation, you go in through a process of looking at the lighting, and you answer a couple of questions, and it then generates the idea, and you can then visualize that idea in something like that at the bottom, in that screenshot, where it gives you in a sliding scale or a color coding where your natural lighting exists. Obviously, you can cut your Revit model to show it better, and there's various ways to do this. And the measurement we used in this particular example was the lux levels. So and you obviously can set up the ranges and that sort of thing, and it'll allow you to very clearly see where you should add your windows, or where you should add shading devices to optimize the harsh lighting, maybe in summer and that sort of thing. Right, obviously worth mentioning in this sort of idea is just the normal Revit shadows and the sun studies within Revit. That is also just a given. It's not included in this whole Insight idea, but it's in the native Revit, where you can do sun studies and shadow analysis and all of that. Right, which will also help you with designing your shading devices optimally and that sort of thing. Right, it's a manual process, so you would do the daylighting analysis, have a look at the images and the colors, go back to Revit, change the windows, add shading devices, and then redo the analysis. So it's not a kind of click button, there we go, magic button sort of scenario. So it is kind of an iterative process to to kind of optimize your model. Right, so that's the daylighting idea done within the Revit environment. Then the next tool, it's also a standalone tool. Think of that. It's not kind of uploading to the web. It's again done inside Revit. Just the tool just next to lighting. It does fall under the umbrella of Insight. In any case, after setting up the orientation and the location, you go into that solar analysis tool, and it then generates again a color coding as well as some report afterwards, showing you the area that you have for possible solar panels, and also what energy you would generate from populating that area with solar panels. And it's kind of got a measurement, and it will give you some costing as well as some saving, and also kind of like a payback time with regards to the cost of the solar panels, the average cost of those. All of these information you can input, and then obviously get the payback of the return on investment years that you can then share with the client and that sort of thing. All right, so then there's another tool on that same energy efficiency insight tool that it's just a button that you press, and it analyzes the report, the model, and it then gives you there's two reports. The one is just a heating and cooling, and then that's an annual overview of how much heating, how much cooling you would have in the model based on certain occupancies and usages and the location and orientation. It's basically just a report that it generates. So it's a kind of a one-way idea. This obviously you can use to further have a look at HVAC if needed. If you need to do HVAC, what's its cost going to be, that sort of thing. And also it's got a detailed report that it's got lots of pages, and there's lots of information in that detailed report with regards to the heating and cooling of each room, each component, each space in each room. Right, it's just a generalized report. So on the other end of the spectrum, once the MEP engineers, they have also a heating and cooling load tool, and that's found under the an analysis tab, heating and cooling loads. And there's a little bit of a process prior to doing the report. You've got more, there's more user input needed, meaning that you can look at each space, and then each space you can define the type of construction, the type of how many people there are, the usage, what is the electrical loads of each space, and the construction obviously of each space. And then you select this heating and cooling loads, and it gives you an informational report as well about each of those spaces and how much liters per second it's required to, in HVAC to solve that particular room. And then you can go and, as a MEP engineer or HVAC designer, go and add your appropriate air conditioning systems for these rooms, even if it's a centralized system, and then you just add up the requirement for each room into this system, and have the liters per second or the airflow that's required to keep that building in a certain set point between 21 or 23 degrees. Right, so that calculational method is more for the MEP engineers, but it's also used in the energy efficiency calculations, meaning that if there's excess or too much, air conditioning needed in a specific room, you might need to just increase the roof, the thermal properties of the roof, maybe in inserting some insulation so that it reduces the reliance on the air conditioning to have that room occupiable or between the set points that's required. All right, so all these features together with the heating and cooling loads, the orientation, location, the solar, the lighting, daylighting, all of it to place together allow you to optimize the building. But I think the main thing is that the decisions get done earlier in the design process rather than as an afterthought. You've now made your design and you think, oh, okay, what is the energy efficiency like? And then you go back and go and do that. But up front, you can design a kind of a bubble diagram or a mass model conceptually, do the calculation, see where you fall flat, change your design, your orientation, and then work your way through. Maybe later on when you start using the construction methods, brick, concrete, whatever, then you can drill down and be more precise in your calculations so that you can optimize your energy efficiency and the design related to that. All right. Okay, so this is just a brief overview of Insight and why and how it originated, and how it can be used to optimize your buildings. Right, there's lots of little clicks and ticks and picks that allow you to optimize the process. If you need more training on this topic and that sort of thing, please send us an email on that link, or just ask about this, and then we can help you and go through the process, do some examples, and make your increase your energy efficiency optimization for your buildings. All right, thank you very much for attending. It is kind of a short webinar, but at least it gave you some insight, excuse the pun, to the whole energy efficiency of tools that Autodesk has. All right, thank you for attending, and I hope you have a good day further. Right, if there's any questions, you can type it in on that chat box, and I will see if I can answer that. Okay, thanks for attending.